Okay, so here it will generate between data 1 and run. So undeclared identifier, just comment this child class. Twenty-seventh line. PA or dot randomize. Explicit lifetime is
local variable PAR.
correct only, right?
Inside with the flower brackets, I think. That data one inside flower bracket. That a square bracket should be inside flower brackets.
Okay, that's why we need to remember syntaxes. Okay, so inside for data 1, it is generating between 5 to 10, and data 2, it is generating 10 to 15. Okay, so the inside, and there is a not inside also. Nothing but inverted inside. So what is inverted inside?
Excluding the range.
So whatever the syntax is very important. So here we need to take the brackets and
Negation.
we can take the inverter. Okay, here also inverter and in the brackets. Okay, so this is what that means. Whatever the values it generated now, without those it will exclude those and it will generate the values. Whatever the values we have taken within the inside, other than that values, it will be generated. So 5 to 10, 5 to 10, other than 5 to 10, it generated all 14, 2, 11, 0, 3, 4, 12, 15, like that. And 10 to 15, other than 10 to 15, it generated all. Okay, so this is the inside constraint. Okay, so we have seen two constraints, inheritance and inside constraint. So what is the next constraint? We'll see inline constraint. So what is mean by inline constraint?
Inline constraint is basically used when we are writing module.
Okay. Uh, in constraints
Then
also we can
randomization.
disable. In constraints also we can enable and disable the constraint. Okay.
Yeah,
So,
yeah, using constant mode, like
mm,
rand mode.
okay. So how can we do that? Suppose if we want to disable the constraint, how can we disable?
We can disable here. Where I can.
Hmm.
In module block, ma'am.
before doing randomization, we can disable, right?
Before randomization.
So same like previous example only. So
Yeah.
whatever the object par dot, what is the constraint name, data
Data value.
value dot, this is the syntax, constraint,
Constraint mode 0.
constraint mode
Understand.
0, so that it will disable that constraint. Other than that constraint, it will generate the values. Okay. So first I'm disabling the constraint here, and enabling the constraint 1. So enable, we'll see both at a time. Enable parent. Okay, now run. So what will be the first display statement and what is the next display statement?
Let us see.
See here it is generating with the same loop, disable, enable like that. Okay. So if you don't want like that, you can repeat this, and you can stop and end here, and repeat next loop again. Okay. So repeat next loop so that end. In that case, you won't find like this disable, enable. Okay, see. First all disable. Disable means these constraints are not generating 5 to 10 and 10 to 15. Other than those values, it is generating. After enable, it is generating between 13 0. After enable also, it is generating same. Okay. After enable also, it is generating same here. Okay, wait, we'll just remove this line and we'll check. For disable, 5 to 10, constraint mode is not disabling. Is that syntax correct? Constraint mode, correct only. Okay, just check here why it is not disabling the constraint. Okay. Okay, we'll check that thing. Next one is the inline constraint. So what is the inline constraint?
Inline constraint we can also use for overriding the constraint, overloading by using soft constraint, soft keyword.
By using soft keyword, we can override. Okay, before that, what is the syntax for inline constraint?
Inline constraints is used with randomized with then range. for in parenthesis bracket if you want to greater than 5 or like.
Okay.
Yeah.
Okay, so I'm just commenting these. Just we'll see first with the inline constraint. So inline constraint will be written in the module with respect to the randomize method. Okay, so here randomize object dot randomize with means it is an inline constraint. Okay, so I'm telling it should generate the data 1 must be greater than 10. Okay, so it will generate the greater than 10, and you can take for data 2 must be generate less than 10. So do the randomize run. Okay, so what is the data 1? Data 1 is a 10 and data 2 is the less than 10. Data 1 is a greater than 10 and data 2 is a less than 10. Okay, so everyone understood the inline constraint here?
Yes, ma'am.
Okay, now my question, I will generate the data in the constraint here. Okay, suppose here inside, just removing the constraint and without taking inside, we'll take the constraint, the range between data 1 must be less than 5 and data 2 is equal to 3. Okay, so what will be the output now?
Output will be accordingly parent class.
Output will be parent class. Okay,
Constant,
is that
yes.
correct? Is that correct, everyone? Is it overriding the inline constraint?
Ma'am, it will be a combination of both constraint.
Okay.
Data one will be greater than 10 and less than 5, not in between the like 10 and 5. I think.
Is that correct? Then what is the need of soft constraint?
So constraint used to.
You just wait. You tell. Okay. Whoever told the answer now. Then what is the use of soft constraint if it is generating between two?
Ma'am, soft constant is basically used to like remove the ambiguity or confusion between the two constraint.
Mm-hmm. Okay.
Mm. So here I think
Mm. Tell.
here I think compiler will get confused maybe like which constraint should follow. So we may use soft constraint here.
If we use the soft constraint, then what is the output?
Uh, if we will use a soft constant, then I think the inline constant will be the output with like whatever the constant we define with syntax, no, that one will be executed.
And the constraint inside the class will be excluded if you use soft keyword.
So I'm thinking that here I will get some error. Do we get the error? Because here the conflict
Yes,
is
ma'am.
getting
Yeah,
within
ma'am.
like
It is like
constraint.
an operation between two conditions. It is like with the and that constraint was in class. So I think data one must be conflict, but data two will get 3. But data one there will be conflict because first is less than 5 greater than 10. So under operation won't be equate. So I think error will generate
Okay.
because of data.
Okay. So here some conflict will be generated between the data 1 and the data 2. Okay, so we'll just run and we'll check. Zero. See, randomization failed.
Zero.
The condition of randomized call cannot be satisfied. Okay, the following condition cannot be met. So randomization got failed. So how can we overcome this thing?
By using soft randomization, soft constraint.
Okay, if I use the soft constraint, then what is the output and where I can use the soft constraint? Where I
So
can
Uh,
use
we
the
will use
soft.
it
soft
in parent.
soft
Inside the
constraint
class.
in parent class. Soft constraint in the parent class, and then that uh, mm, with like inline constraint, like data 1 greater than 10 will be randomized.
Yes, yes.
Okay, then what is the output of data 1 and data 2?
Data 1 will be
Data
greater
1,
than 10 and
yeah.
data 2 will be 10.
Huh?
Inline constraint will execute, ma'am. Data 1 value will be greater than 10 and data 2 less than 10.
Okay, good. So here we are keeping soft. Okay, so if you use the soft, so the inline constraint will override the soft constraint. So
So constraint.
whatever the data 1 is getting greater than 10 value and data 2 is getting less than 10. Okay, here it is overriding with a 3. Okay, if you see, I'm just putting less than 5. After checking that, we'll check this condition. Okay, equal to 3 means it will override again. Okay, see, it is generating less than 5. How it
This
will
one working like
generate?
a soft constraint.
Okay, then wait, greater than 10. Randomization failed.
Actually,
Okay, but saw
one second.
data 2
Ma'am, there
also we
is
need
we
to
have to
put.
wait. Yeah, yeah. Soft with the both
Okay. Yeah,
data variable.
remember this thing, everyone.
Yeah, yeah, yeah.
Okay. Uh, for data 1, it is generating. Okay, with
Correct,
Fine,
ma'am.
ma'am. Fine.
data 2 must be generated
Less than
less than 10. Yeah, it's
correct.
generating, right? Okay.
Yes, yes.
So inline constraint is working. Okay, soft constraint. So, so mainly we have top level classes, right? Mainly, if you see practical way, if you observe, suppose I'm showing some example for you. So here we have the transaction class. So what is the transaction class? Class transaction. These are the different number of inputs. Okay. If you see the design here, the top level calculator. So this is the port list. Okay. Output data 1, data 2, response tag, request data input tag, command line. These are the inputs. So these are the different number of inputs are there. For these different number of inputs according to the specification, okay, according the specification, we have written the constraint like this. Okay, the request one command in must be generate the values only 1 to 5 6. So we use insight. 1 means addition, 2 means subtraction, 5 means left shift, 6 means right shift. Okay, like that. So request to command in 1 to 5 6, request 3 command in 1 to 5 6, request for command in this. Okay, but some certain cases I don't want to use this constraint. I want to take a new constraint. Okay, without removing this constraint, I want to take a new constraint. Okay, so how can we take that new constraint by using this soft functionality, by using this soft keyword? How can I take the new constraint?
using inline
for some temporary purpose, okay, for some time I don't want to use this constraint, I want to check with some new constraint, okay, but these are the permanent constraint. For temporary use, I want to create some constraint and I need to check. Then how can we check?
We can disable this constraint.
Okay,
Yeah, by using constraint mode, and new constraint we can write it here.
then what is the use of soft?
Okay.
Ma'am, here we can use soft constraint and then further we can add our constraint, extra whatever constraint have with the inline constraint.
Yeah,
Okay,
we need to create inline constraint and soft constraint in this constraint soft
okay.
keyword.
So while
Yeah.
the generator, in the generator, while we are doing the randomization, by using the inline constraint, whatever the temporary randomization, whatever the constraint you have, the scenario, whatever you want to verify, you can put that scenario with the randomization here within the randomization method by using the inline constraint, and this permanent constraint, okay, whatever the transaction class we have, the permanent constraint, you can just put soft for that constraint. Then automatically, whatever you want to check the temporary constraint now, that will be executed, right? That will be override our permanent constraint. So this is the actual scenario why we use the soft constraint. Okay.
Okay, ma'am. Okay.
Okay, ma'am.
Okay, everyone
Ma'am,
got clarity? Yes, tell.
ma'am, can you explain? Can you open that calcify? Ma'am, this operator, scope operator. So line number 22.
Okay.
So, ma'am, if we didn't use this, just like we just wrote like a task run. So, what difference it makes? I mean, what is the extra feature that we'll get after writing generator scope operator run?
See here, generator means just it is showing, it is pointing to the parent class. Okay, it is just pointing to this parent class. Okay, if you put directly task run means that is just run. Okay, it doesn't know whether it is in this particular related to the class. It is related to the class only because we are writing with respect to the class, but it is telling that this particular task is related to the generator. Okay, because this is not in the this function or this task, we are not writing within the class, right? Actually we need to write within the class, we are writing externally. If you see here function generator, so function generator, actually we need to write this function within the class. We are not writing within the class to point out that this task is particularly mentioned to the generator. That's why we are writing generator,
Yes.
nothing but externally. Externally, we
Correct.
are
Yeah,
defining the function and the task. Okay, that's why with the scope resolution operator, we are pointing to that particular class and particular generator. Okay, maybe if you don't write like this function, it doesn't understand that this function is related to the generator class, because that is outside the class. In the same file, you can write for driver also. You can write for driver also, because this is not related to the class, this is not inside the class. So you can write any code here, I mean any function or any task here, any component. Okay.
yeah, got it. Because I didn't see the end class first because I saw the bottom first.
Mm,
So I thought inside class we are using that. Yeah, now I got it. Right.
mm. Okay. Okay, so this is somewhat coding style. So when you are practicing with more examples, so you'll get the coding style. And if you see here, extern function, extern virtual, that's why we mention here extern, because we are taking these things externally to the class. Okay, So have you understood the soft constraint, everyone?
Yes, ma'am.
What are
Yes,
different
ma'am.
constraints are there? Still distributive constraints are there.
Distributed gated type.
Will give the distributive means will give some weight. Okay. Just try the distributive yourself. And unique constraint is there. What is mean by unique constraint?
Unique constraint means to generate unique values.
Hmm. Okay.
Implication constraints.
Implication constraints.
Implication operator होते हैं.
Implication operator.
Using implication operator.
Yeah.
Okay, remaining constraints we'll see tomorrow. Okay, tomorrow or one session we'll
Okay.
see leftover topics. Okay. Okay, everyone understood today's session?
Yes, ma'am.
Okay, everyone understood, right? Okay, then please practice. Okay.
Okay, ma'am.
Okay, then thank you, everyone.
Thank you, ma'am.
Thank you.
Thank you.
Good night to all.
Yeah, good night, everyone.